Start with the reactions of Grignard's reagent. First of all, we are going to see the reactions with aldehydes and ketones. Now the reaction with aldehydes and ketone, this is done to produce primary, secondary and tertiary alcohols. These reactions are carried out in the presence of ether followed by acidic hydrolysis, means the breakage of water in the presence of acid, and the H and OH is going to react in the chemical reaction. Now students, before going into the reaction, let us see that how alcohols are classified. The classification of monohydric alcohols are as follows. Now what are monohydric alcohols? Means alcohols having only one OH as a functional group. Alcohols can have more than one OH. They are called polyalcohols. This is the classification of monohydric alcohols, means alcohols containing only one OH group. Primary alcohols are those alcohols in which the carbon to which the OH group is attached is further attached with one carbon atom or none. Secondary alcohols are those in which the carbon to which the hydroxyl is attached is further directly attached with two carbon atoms. They are called secondary alcohols. Tertiary alcohols are those in which the carbon to which OH group is attached is further directly attached with three carbon atoms. These alcohols are called tertiary alcohols. Now students, let us see how these three alcohols are prepared. If we have to prepare a primary alcohol, then we react formaldehyde with Grignard's reagent. Now you can see this is formaldehyde, HC double bond OH. We are going to react it with a Grignard's reagent, which is going to act as a nucleophile. This carbon bearing a partial negative charge is going to attack on this electrophilic carbon center of this carbonyl functional group, and as a result, this pi bond is going to be broken down, reside on oxygen as a negative charge, and that negative charge is going to attach with this magnesium. And you can see a bond is formed between this CH3 and this C, CH3 and C. These are the two hydrogen atoms. Now the pi bond is broken down, converted into a sigma bond, and this oxygen atom is making another bond on the other side with this magnesium. Now students, the second step is the acidic hydrolysis. We also call it the workup step, in which we are going to get a stable product. Now you can see the negative charge on the oxygen is going to abstract a proton from the water molecule, and this magnesium is going to get attached to this hydroxyl group, giving you a primary alcohol along with hydroxy magnesium bromide. Now you can see this is a primary alcohol because the carbon to which the hydroxyl group is attached is further attached with only one carbon atom. That is why it is called a primary alcohol. Now students, why have we used formaldehyde? Because this carbon is attached to two hydrogen atoms. In this way, this is going to be a primary carbon atom, giving a primary alcohol. Now students, if we wish to synthesize a secondary alcohol, then we are going to react any other aldehyde except for formaldehyde with Grignard's reagent. Now students, you can see the aldehyde that we are taking is ethanol. Formaldehyde had two hydrogen atoms, but over here we are having one hydrogen atom and the other one is a methyl group. We are going to react Grignard's reagent in the same process, in the same pattern as we have reacted it with formaldehyde. The CH3 is going to act as a nucleophile and is going to attack on this electrophilic carbon of the carbonyl functional group. The pi bond will be broken down and make a bond with this magnesium, giving you an intermediate in the second step, which is going to be the acidic hydrolysis or workup. The oxygen carrying a negative charge is going to abstract this proton, and hydroxyl will attach to magnesium, giving you a secondary alcohol along with hydroxy magnesium bromide. Now students, this is a secondary alcohol because the carbon to which this OH group is attached is further directly attached with two carbon atoms. That is why it is a secondary alcohol. Now you understand why we are having any other aldehyde other than formaldehyde for the preparation of secondary alcohol, because in that case we will be having a R group on one side, so that this carbon will be acting as secondary carbon, giving a secondary alcohol. Now students, in order to synthesize a tertiary alcohol, we are going to react the Grignard's reagent with a ketone in this case. This is a ketone CH3, C double bond O, CH3. Now students, we are having two methyl groups with a ketone, and the third R group will be added from the Grignard's reagent, making this carbon as a tertiary carbon. That is why we will be having tertiary alcohol in the end. The mechanism is similar to what we have studied. This CH3 is going to act as a nucleophile, attack on this electrophilic carbon. This pi bond will be broken down and it is going to get attached to magnesium, giving you an intermediate, which is going to react with water in the presence of acid, which is called acidic hydrolysis or workup. This O negative is going to abstract a proton, and OH of the water will be attached to magnesium, giving you hydroxy magnesium bromide along with tertiary butyl alcohol. You can see this carbon is directly attached with three carbon atoms. That is why it is tertiary butyl. Why butyl? Because we are having four carbon atoms. Alcohol, because OH group is attached. So in order to synthesize tertiary alcohols, we react any